If a seed is planted, it has a 75% chance of growing into a healthy plant. If 9 seeds are planted, what is the probability that exactly 2 don't grow? Now, if you check that this follows a binomial situation, that is, check the 4 criteria, there's a fixed number of trials, each trial has the same probability, the trials are independent, and there are only 2 possible outcomes for each trial. That is, either a plant is going to grow into a healthy plant or it's not. This meets the criteria, so this is indeed a binomial situation. Now, if we want to calculate the probability that 2 don't grow, let's record what we know. For binomial, we need an n, that is, total number of trials. In this case, we're planting 9 seeds. Our x is the number of successes, that is, 2 not growing. Now, it is a little strange to think of not growing as a success, so if you want, we could do it 9 and 7 being the success, in which case you have to change your probability of a success from 25%, which is the probability it doesn't grow, to 75% chance that it does grow. So I'm going to call 7 my number of successes. That means my number of failures is 2. So now my probability of success then, that is, these 7 are my successes, that means probability of success must be the probability of one of them growing into a healthy plant. So that is the 75%. That means my probability of failure, or my Q, is 25%. So we know the binomial probability formula is given by n factorial over n minus x factorial times x factorial times the probability of success to the number of successes power times the probability of failure to the number of failures power, which is n minus x. So plugging all this in, we can find the probability of 2 in this situation is going to be 9 factorial over 9 minus 2 factorial, or just call that 7. Excuse me, we decided to call the number of successes 7. So I'm going to change this. So that should be 9 minus 7 factorial times 7 factorial. Now my probability of success is 0.75 to the 7 successes. And that means my probability of failure will be 0.25 to the number of failures, which is 2. Now, to plug all this into the calculator, I'm going to use my TI-30X2S. So I've got a couple different ways to plug this in. So the long way is to say 9, and then to find the factorial, I'm going to use the PRB button. That gets me 9 factorial. Now I'm going to divide by, and now I'm going to wrap the entire denominator in parentheses. So I'm going to do the 9 minus 7 and call it 2, give that a factorial, times 7 factorial. And now I multiply times the probability of success, 0.75, to the 7th power times 0.25 to the 2nd. And that gets me the probability of 7 plants growing into a healthy adult plant. Now, we have an alternative way to calculate this part. If you recognize this from maybe a previous section on counting, this is really just n choose r, or in this particular case, 9 choose 7. So I could instead call this 9 choose 7, and then multiply 0.75 to the 7th and 0.25 to the 2nd. Now let's see how to do NCR on the calculator. So to calculate NCR, or in this case 9 choose 7, I hit 9, go back to my PRB button, and you might have noticed we passed this NCR. If I stop there instead of going to the factorial, then I am doing 9 choose, and I'll type 7, and then multiply everything else. That was 0.75 to the number of successes times the probability of failure, 0.25 to the number of failures. And I'm given 0.300 as the probability. Now, if I wanted to calculate this in a spreadsheet, I'm going to give you a few different ways, starting with the most laborious to the easiest. The first way, I could use the fact formula, which calculates the factorials. So this would be, I would say, equals fact 9, that will be 9 factorial, divided by, and now I'm going to wrap this whole thing, the whole denominator, in parentheses. Fact 2 times fact 7, and then close those parentheses. And now I can multiply by my probability of success to the number of successes times probability of failure to the number of failures. Give it a second to calculate, and there's my probability of 7 successes. As an alternative, spreadsheets, and Google Sheets in particular, but I believe this works in Excel, has the combine function, and this is basically your NCR. So my N in this case is 9, and the number of successes they're calling K if you look at the formula carefully, but K, R, or X, just depends on what you're looking at, but it's the number of successes. That is in place of all the factorials. So that's my NCR right there. So now I can multiply that times 0.75 to the 7th times 0.25 to the 2nd. Now as a third way, there is a formula in here that will do the entire binomial distribution for you. It is binom.dist. And it will ask you for the number of successes, we want 7, the number of trials, we have 9, the probability of success, 0.75, and notice it's not asking us for the probability of failure because it can calculate that if it knows the probability of success. And now here, it asks for cumulative. Cumulative, we would say true here if we wanted the probability of 7 or less. But since we want exactly 7, we're going to say false. And that calculates the probability all in one fell swoop.